Alright, so the blue line represents the airplane having no paper clips on it, and then the red line has the airplane having two paper clips, and the yellow having four, and the green having six. And by our data, with no paper clips, the plane goes further.
Our measured variable was height, and our three variables was standing on the ground, standing in a chair, and sitting in a chair, which are represented on the graph as blue, red, and yellow. We measured the distance the plane flew. That was measured in meters, and on the ground the numbers were pretty consistent, but standing on a chair and sitting in a chair, they were not consistent because there were several outliers.
Hello, I'm Ollie Shalabi.
I'm Joshua Burke.
I will be doing A, standing on the ground variable.
I will be doing B, standing on a chair variable.
The farthest the standing on the ground variable went was 9 meters, and the smallest was 3 meters. As you can see, there is an increase in the meters. Trials 3 through 7 was really consistent.
The shortest distance was 4 meters, and the longest distance was 9 meters.
Wait.
The resulting pattern was very inconsistent.
Overall, standing on the ground variable succeeded more. That was our graph. Thanks for watching.
As you can see in plane A, it was consistent until trial 4 because it didn't go as far as it did before. But in trial 5, 6, it became consistent again. In plane B, it wasn't as consistent as plane A because we folded the wings and we lost total control. As you can see, in trial 4, it becomes 3 times more, which lost control.
We had several anomalies where the plane would throw in a 360-degree spin, and we had no idea why.
Okay, so this is our paper airplane graph. The blue part is the first plane, and it did not have a consistent rate, and it was kind of floppy, so it didn't go as far as the other one.
On our second airplane, we added paper clips for more weight, and it was more successful. We added the paper clips to the back, which caused it to go higher and have more consistent flight. This shows that adding weight to the back improves flight.
Our title of the lab is Airplane Height Experiment, and we're experimenting if the height changes how far the plane flies. The y-axis represents the distance in meters, and the x-axis represents the 5 trials. The green line represents the plane thrown from a chair 42 centimeters high, while the blue line represents the plane thrown from the ground.
At the start of the trial, the results were more spread out. In the middle, the results became closer, and at the end, the results overlapped. We can conclude overall, thrown from higher, the plane gets more distance.
Our experiment was how does height affect the distance of a paper airplane? The 4 different heights we used were sitting down, kneeling, standing on a chair, and standing on the ground. As you can see, the variable we used was height.
We tested the plane 5 times from each height as shown on the x-axis. We measured the distance traveled in meters as shown on the y-axis.
We found that standing up had the highest average distance, which was 7.7 meters, and we found that sitting on the ground had the lowest average distance of 5 meters. From this, we conclude that the higher up you are, the farther your plane will fly. It's not pausing. Stop.
This is our average distance of plane graph where we're trying to test which height would make the airplane travel farther. The x-axis represents the height we threw the airplane at, and the y-axis represents the average distance traveled in centimeters. We took 4 tests for each height and averaged them.
At 103 centimeters, our test average was 519 centimeters. At 149 centimeters, it was 684. And at 184 centimeters, it was 345. Looking at the results, 149 centimeters traveled the furthest, then 103 centimeters, then 184 traveled the least. This was because the plane would hit the ceiling.